Greetings to Algebra 2 students. I appreciate you finding time to tune in and get your notes taken care of. For today and the next day or two, we are going to be kind of tying everything in together from all of the Unit 5 stuff that we've been doing, kind of filling in the missing blanks and seeing what the puzzle looks like when it is all assembled. Today, we're going to be looking at forms of quadratic equations. Our objective for this day is that the student will learn to convert between standard and vertex forms of quadratic equations. Like many things in mathematics, there is more than one way to express a quadratic equation, so we better get accustomed to the different ways that it may look so that we can recognize it when we see it. As always, press pause anytime you need more time, and then hit play when you're ready to move forward. Let's get to it. We should be familiar with the format that is on the screen right now. Okay, this is one of the main forms for a quadratic, and this is what we call standard form. Okay, standard form is kind of a generic term, and typically what it means is all of the pertinent variables, are on one side of the equal sign. Now, as I've suggested before to you, the x-axis in mathematics is the one that is truly important. The y-axis is just kind of a side effect of what the y-axis does. That's why they call the x-axis independent and the y-axis dependent. So all of the information regarding the x information is on one side of the equal sign. That's what we call standard form. We've worked with it before. But it's not the only way that a parabola can be expressed. There is another popular form which you actually may find more convenient than standard form when it comes to quadratics, and that form is what we call vertex form. Vertex form states y equals the quantity of x minus h squared plus k. And the reason it is called vertex form, and the reason for these new variables h and k, is because the location h comma k actually positions the vertex in the graph. Now get used to the idea of h representing x of a vertex and k representing y of a vertex, because as you're going to see later on this year, we're going to get into a deeper discussion of parabolas and what are known as the conic sections. Okay, and this h comma k idea is going to still be true throughout all of those discussions. Please notice in the formula that the sign between x and h is minus. It is built into the formula that way. It is supposed to be that way. So if you see an equation that does not reflect a minus between those two values, then that must mean that h has its own negative to cancel the negative of the formula out. But we'll come back to that here in a moment. Now, both of these formats are used interchangeably. It is just as likely that you will see one of these formats as the other. Okay, it just typically depends upon the preference of whomever is assembling the problem. Some mathematicians love standard form, some love vertex form, and there is really no tendency to use one or the other. So the bottom line is we had better be familiar with both of them, and we had better be able to convert between the two of them accurately and dependably, because one of them has uses as far as factoring, that would be standard form, and the other one has uses as far as identifying things like a vertex, and that would be the vertex form. All right, that is all of the new information. Let's see how the math works. So let's say we have an example such as this, and we are given instructions point blank to convert to standard form. Now, typically, the instructions you have on problems like this are not going to tell you to convert to a particular form. It'll be up to you to decide, oh, if I were looking at this equation in the other format, then that would be more useful to the question that I'm trying to answer. Okay, so let's just assume that we have decided that this needs to be converted to standard form. Well, this is a discussion from back in the simplifying of polynomials. Okay, right off the bat, you ought to notice that we have a polynomial being squared. That means that x minus 3, that binomial, needs to multiply times itself. So x minus 3 times another x minus 3. The plus 4 at this point is just hanging on for the ride. And here we go. Please excuse my dear Aunt Sally. The multiplication needs to be done before we can get to the addition. Okay, so basic rule of multiplying polynomials, everything from the left polynomial needs to multiply by everything in the right polynomial. Okay, so doing the distribution, x times x will be x squared, x times negative 3 will be negative 3x. Scooch over to the negative 3 on the first binomial. Negative 3 times x is another negative 3x, and negative 3 times negative 3 is, of course, positive 9. So there is the expansion of those two binomials being multiplied. And then our next step should be to combine like terms. There are no other x squared, so there will be 1x squared. There are negative 3 x to the firsts, and then negative 3 more x to the first, so that will be negative 6 x to the firsts. And 9 constants, and then 4 more constants is 13 constants. And there you go, simple conversion. The standard form of the equation that we started off with is x squared minus 6x plus 13. Okay. On the flip side of that, we could convert back to vertex form. Okay, so let's say we have a standard form of x squared minus 6x plus 3. And again, typically problems are not going to come out and say, here is an equation, convert it to vertex form. It'll be up to you to decide, I've got an equation here, it's in standard form, but it would be more convenient if it were in vertex form so I could answer whatever question it is that I'm trying to answer. So assume we've decided that we would want to convert to vertex form, so let's do it. Now here's where all of the factoring skills come into play. The first thing you would do is to look for terms in common between the terms of this trinomial, and clearly they have nothing in common. Your next instinct would be to go for the a times c method. Okay, so a times c in this case, 1 times 3 would be 3. We would take our 3 and factor it down all of the different ways that it can be factored, which in the case of a 3 is only 1 times 3, because 3 is a prime number. And then we would search for a way to add or subtract the pairs of factors that we see in order to try to match our b term, which is a negative 6. So clearly, that's not happening. So the a times c method is a failure in this case, and that would deliver us into the hands of completing the square. If we cannot factor by the a times c method, completing the square is pretty much the only option that we have. So we would take our equation, x squared minus 6x plus 3. We would move our c term to the other side of the problem, so that would involve subtracting 3 from both sides. After that, you would have on the left y minus 3, and on the right, x squared minus 6x, and that would be all. Okay. Now what we would want to do is we would want to complete the square over on the right side of the problem. Okay. Now if you remember, completing the square means taking your b term, halving it, and then squaring it. Okay, well, your b term is negative 6. You do not need to worry about the negative because in the end, you're going to square this value. That is always going to result in a positive number. So take 6, half it, that would give you 3. Square it would give you 9. We're going to add 9 to both sides of the problem. Okay. Now clearly on the left side we have two constants that we can combine, negative 3 and positive 9. That would be positive 6. Over on the right side of the problem we have generated a perfect square trinomial, which means that trinomial can be factored into a binomial squared. The lead term will be the square root of x squared, that is x. The trail term will be the square root of 9, that will be 3, and the sign between them will match the sign of your b term as it is right now, which would be minus. So there it is, y plus 6 over on the left, and the binomial x minus 3, like we said, would be then squared. The only thing left to do is to bring the 6 back to the other side of the problem to get it into basically standard and vertex form. Are going to have everything over on the right side. So we're going to subtract 6 to the other side. And keep in mind that minus 6 cannot get inside of those parentheses and affect the negative 3 because that binomial is being squared. The order of operations would have to be simplified before the negative 6 could try to get any other constant. So it's just going to hang on to the end like you see there. Y equals x minus 3 squared minus 6. There you go. That would be your vertex form. There's nothing more to really understand here other than just getting the math down and getting a little bit of practice. So that's going to be our function at this point. Okay, I'm going to give you 2 examples. I expect you to try these. If you do not work these out on your paper, okay, that will be a reason why you will not receive full credit on your notes. If you do not understand how to do it, simply showing up and saying, I didn't get it, is not going to be an explanation. If you don't get it, come in, ask questions, get help. Okay. Now here is an equation. It is in vertex form. Y equals the quantity of x minus 3 squared plus 4. And you are asked to determine the b value. Now again, I told you that problems are not going to come out and tell you, I need you to convert this to standard form. But you need to recognize in order to answer this question, you have to have it in standard form. Ax squared plus bx plus c. You cannot read the b value out of vertex form. So copy that one down and work it out. And one more. Where is the vertex of y equals x squared minus 8x plus 3? And once again, the problems are not going to come out and tell you I need to be in vertex form. Please change me. Okay, but you have to recognize the only way to read the vertex out of the equation is to get the equation into vertex form. So convert it into vertex form and then read back in your notes h comma k. Where do they come from? That will show you what your vertex is. So copy this one down, work it out as well. I appreciate you finding time to take care of your notes, and I will see you in class.